Now, the next question we're looking at is a body on a free fall. Okay. Now, look at this question. A body of mass 3 kg falls from rest from a height of 300 meters. Calculates its kinetic energy after falling a distance of 125 meters. Now, this is very easy to be solved. Now, what are the key facts here, or the things I should take note of, is kinetic energy. That is one. Now, the next thing I should take note of is that it is falling from rest, okay, from a height. So let me just be like, okay, let's assume that this is the object and it falls to the ground. Here is the ground. Let's take, for instance, here is the ground where it fell, and we were made to know that the height is 300 meters. So we ask, calculate its kinetic energy after falling a distance of 125 meters. After it must have fallen a distance of 125, that is, from up, it has fell a distance of 125. Let's assume that from here to here is 125 meters. So now I can solve it in two ways. The first way through which I can solve this is to use the formula for kinetic energy, or I can still solve it using the principle of potential energy. I'll still get the result. Thereby getting the potential at maximum, the potential at this point, I can easily get the answer. So now, how do we go about it? Now, I'm going to apply two formulas. Now, but the next thing is this. When something is falling from up, what acceleration is it falling with? You know, gravity says anything that goes up must surely come down. So gravity is dragging everything down to the earth. Gravity is dragging everything. So since it is falling, it means it is in support of gravity, because gravity says everything up, please come down. So it is falling. It means that A is equal to positive G, because it is falling. So it is supporting gravity. Had it been we are throwing something up which is going against gravity, our acceleration will be minus G. Okay, but in this case, this thing is falling from up. It is falling from up, so it is in support of gravity. So this is equal to 9.8 meter per second squared. That is the value for G. Now, next thing is this. Since it falls from rest, in fact, anything that is falling from above definitely falls from what? Rest. So it means that our initial velocity U is equal to what? 0. Okay. Now, the next thing is this. Since it is falling from rest, our initial velocity is 0, then when it will bounce on the ground, because as it is falling, it is gathering momentum, so there must be a velocity at which it will use to land on the floor. So the final velocity needs to be determined. Okay, so I can go to Newton laws of motion. From there I can get the required formula for this. So the first thing I have to do to make things easy, I know that first law, we have the first formula, V is equal to U plus AT, and I know that S is equal to UT plus 1 over 2 AT squared, and I know that V squared is equal to U squared plus 2AX. So now I have my distance. Okay, the distance from this to this is 300 meters. But they're asking when it has fell a distance of 125 meters. Okay, so I can take a distance x of 125 meters, because that's what they're asking, when it has fell a distance of this. And again, I know that my initial velocity is 0. Then my final velocity needs to be determined. Okay, and acceleration is already given to me to be what? 9.8. So for me to be able to obtain the kinetic energy, I must know what my final velocity is, because which velocity did it use to land on the floor? So I need this for me to get my kinetic energy. Remember that kinetic energy is given as 1 over 2 mv squared. So this v is the final velocity at which it hit the ground. So I need this. So which of these formulas will enable me to obtain my v? If you check the third formula, v squared is equal to u squared plus 2as. This has to do with v, it has to do with u, it has to do with A, acceleration, which is positive 9.8, and again it has to do with distance. So I can easily get my V here. So it means that V squared is equal to U squared, which is 0 squared, plus 2. A is 9.8, which is the value for gravity, and X is 125. Okay, so V squared is equal to 2 times 9.8 times 125. 2 times 9.8 times 125, because they said when it fell a distance of, so I'm not using the distance of 300 meters because this is the maximum height, but they say when it has fell, so I'm neglecting this. But when you're going to work with this is when you're solving using potential energy approach. Okay, we're still going to apply that same one, we're still going to get the same results. So 2 times 9.8 times 125 will give us 2450, which means that our V will be square root of what? 2450 meter per watt second. So if I convert this square root of my answer, I'm going to have that V is 35.2 meter per second. So this is our what? Velocity. The velocity at which the object land the ground or land the floor is this. So what is my kinetic energy now? My kinetic energy is 1 over 2 mv squared. So kinetic energy is equal to 1 over 2. What is our m? The mass of the object is 3. What is the velocity? 35.2. Then it has a power 2 here. So this is power 2. So our kinetic energy, if I put everything in my calculator, 1 over 2 times 3, which is the mass, times, then this is 35.2, bracket close, raised to the power 2. So the energy, the kinetic energy at which this object hit the floor is 36.75. Okay, the energy at this point, okay, what's the kinetic energy after following the distance of this? After following the distance of this, it has a kinetic energy of 36.75 joules. Now again, which other way can we solve it? Like I said, we have two methods. I can go through the principle of kinetic potential energy. Okay, so using kinetic energy principle, I know that kinetic energy can be equal to the potential energy at maximum height, potential energy at maximum height, that is potential energy at 300 meters minus the potential energy when it's at 125. So if from here to here is 300 meters, then what will be from here to here? Since from here to here is already 125. So look at what I'm going to do. What I'm going to do in this situation is that I'll get the potential energy at 300 meters, and again I'll get the potential energy at the difference between 300 meters and 125. That is from here to here. I'll get the potential energy from here to here, then I'll also get the energy from here to here. So the difference between the total energy from here to here and from here to here will give me my what? Kinetic energy. So for now, let us get the potential energy. Potential energy at distance of 300 meters. So formula for potential energy is equal to mg what? H. So m is what? 3 times what is g? G is 9.8 times the maximum height, which is 300 meters. So find out that our potential energy will be 3 times 9.8 times 300. So this will give us 8820 joules. 8820 joules. Now again, what is the kinetic energy? What is the potential energy after it has followed a distance of 125 meters? So here, our height now will be total distance minus 125. So that is from here to here. So I'm looking for the height from here to here. Okay, so potential energy again at this point will now be equal to mg into h2 minus what? h1. Okay, so our potential energy here will be equal to what is our m? 3 times 9.8 into what is our h2, which is 300 meters minus our h1 is what? 125. So potential energy here will be equal to 3 times 9.8 times 300 minus 125. 300 minus 125 should give us 175. So our potential energy at this point, remember that this is at the maximum height, so this will now be equal to 3 times 9.8 times 175. So this will give us 5145 joules. Okay, so the kinetic energy now is the difference in this, the difference in potential energy at point 1 minus potential energy at point 2. So this will be equal to 8820 minus 5145. So this will be equal to 8820 minus 5145. So this will give us 3675 joules, which is the same thing as this. So anyone you use, okay, definitely you'll get the result. Okay, just know what you are solving. Okay, just know what you're solving. You can apply this method. You use Newton's law, you know, the third law to get your velocity. You apply to this. This is the formula for kinetic energy, kinetic energy, and you can still apply the principle of potential energy. You still get the same result. So whether this or this, anyone you apply will definitely go.